Hello, everybody. Today, we're going to begin our discussion of Chapter 16, our last chapter. And Chapter 16 is a chapter that really is the logical culmination of everything we've done. We started out with just the individual household, and we built a model of individual demand for a utility maximizing household. And then we aggregated those demands into a demand side of the market. And we built our supply side beginning with the individual firm in a competitive market. And that firm, profit maximizing firm, then we used our model of that profit maximizing firm to put together the firm's short run and long run supply curves. And then aggregated those firms into the supply side of our market. And then we put the demand and the supply sides together for our market. We identified what equilibrium looks like in this competitive market. And we also then considered the equilibrium aspects of this competitive market equilibrium. That is to say, its efficiency characteristics in terms of maximizing aggregate surplus. Now, what we want to do is we want to put the markets together. And when we put markets together, competitive markets together, we have a competitive economy. So we will have started from that individual unit on both sides of the market, and we're going to finish with an economy composed of many, many markets. Now, our issue here is that we're going to, keep it simple. We're going to deal with just an economy comprised of two markets. But the key here is that these markets are interdependent. And we're going to consider the nature of interdependency through the demand side. That is to say, when we know markets are interlinked, when goods are either substitutes or complements for consumers, so that what happens in one market is going to have necessarily an effect on the other market. And I might think of this as the example we're going to work through today is the one in the textbook. That is to say, ice cream and pie, which are treated as complements in the textbook. Myself, I would think of them as being substitutes, but the authors in the textbook treat them as complements. And, if we think about both of these markets being simultaneously in equilibrium, then one of the determinants of demand in the ice cream market is the price of pie. And one of the determinants of demand in the pie market is the price of ice cream. So for these markets to be simultaneously in equilibrium, it means that whatever the equilibrium price of pie is, has to be consistent with the level of demand that generates equilibrium in the ice cream market. And conversely, whatever the equilibrium price in the ice cream market is, has to be consistent with the level of the price of ice cream that generates a level of demand that produces the equilibrium price of pie that we observed on the demand side of the ice cream market. So it's sort of complicated. Now, let me real quickly just jump to a PowerPoint, and this is from your textbook authors, publisher, talking about the nature of general equilibrium. So, to distinguish again the terminology, partial equilibrium analysis focuses on a single competitive market all by itself, just treated in complete isolation. Now, when we looked at demand for whatever market we're looking at here, suppose we're looking at doing a partial equilibrium analysis of the market for widgets. We considered one of the determinants of demand being the price of substitute to widgets, and we considered, the price of complements as being a determinant in demand. But we didn't worry about what determined the price of either that complement or that substitute. We just took that price as given and fixed, and we used those prices of these related goods to establish a given level of demand. And then given supply, we found what the equilibrium price would be in this particular market of widgets that we're looking at. But when we move to general equilibrium, now we have to recognize these market interdependencies. And when we look at, the market for widgets, we have to think about the market for doodads, because whatever happens in the market for widgets is going to affect the market for doodads, if they're substitutes, let's say. And whatever then happens in the market for doodads is again going to feed back into the market for widgets. So, there are these ripple effects across the markets, and they go round and round and around, and we get then also these feedback loops. Now, what does general equilibrium in two markets look like? Well, here's the ice cream market, and this would be the equilibrium in the ice cream market when the price of pie was $12. So of all the determinants of demand, including the price of pie, because these are treated as complementary goods, when the price of pie is 12, then this is the level of demand we observe in the ice cream market, and it generates an equilibrium price of 6. Now, for this to be a general equilibrium, that means that the level of demand in the pie market, and one of the determinants of that level of demand in the pie market is the price of ice cream, and so we fix the price of ice cream at 6. That generates this particular level of demand in the pie market, and the pie market then is in equilibrium at 12. So that 12 then determines this price of pie over in the ice cream market, and this 6 here determines then level of demand in the pie market and its price. But as you can see, then we are in a general equilibrium, because unless some other determinant of either supply or demand changes other than the prices in these two markets, there is no reason for demand or supply to shift in either market, and we remain in a simultaneous equilibrium. So what we want to do is we want to solve for what the set of general equilibrium prices would be. Now we're going to do this in just, an economy composed of two markets. It can be done for any number of markets. It's just that the mathematics becomes far more complicated when you're doing it for, n markets, where n could be a very large number. But the principle and the recognition of these interdependencies is identical, whether it's 2 markets or whether it's 20,000 markets. So what we're going to do here is just a simplified version of what is done on a far more sophisticated and complex level when you're trying to model a complete economy. But in order to model an economy, you have to take all these interdependencies into account. You can't just look at the partial equilibrium analyses that we've been doing to this point. So here's our idea here. What we're going to do is, let's start with the market for ice cream here. And here's the supply curve for ice cream. And so since we're dealing with an interdependency based on this complementary relationship in consumption, we'll just focus on changes on demand side. And here is what we're going to call our market clearing curve for ice cream. And let's look at how we derive the market clearing curve for ice cream. What we do is we pick a price for pie, any price, it doesn't matter, $6. And given the other determinants of demand, which we're going to think of as being held equal, they're probably identical in both markets. These are, the markets for ice cream and pie that, are in the same population. So things like income and taste and preference and whatnot will be identical in the two markets. But anyway, so we just pick an arbitrary price for pie, let's say $6, and then that establishes the level of demand for ice cream. And that level of demand generates an equilibrium price in the ice cream market of $8. So we have a pair of prices here. What we're putting on the vertical axis is the market clearing price of ice cream given the price of pie. And so when the price of pie rises, because these are complementary goods, demand for ice cream falls. And so when the price of pie goes to $12, then suppose that demand for ice cream falls to D2. And that's associated with now a lower equilibrium price for ice cream. And that equilibrium price is now 6. So that when the price of pie goes to 12, equilibrium price of ice cream is 6. And we do one more of these, let the price of pie go to 18. Again, demand shifts down or left in the ice cream market, and we end up with a new equilibrium price in the ice cream market of 4. So these are just 3 points. We could think about, price of pie going $6, $6.01, $6.02, 3 cents, and so on. And we would trace out then this market clearing curve for ice cream. And again, I say this is, the market clearing price for ice cream for every price of pie. Now we can do the same for pie, We can generate a market clearing curve, and I'll do that in just a minute, for pie. And we would do the same thing. We would look at the market for pie. We would pick an arbitrary price for ice cream and find what the market clearing or equilibrium price of pie is given that price of ice cream. And so I would generate a market clearing curve for pie. Well, if I put these two market clearing curves together, like I have here, here's a market clearing curve for pie, here's a market clearing curve for ice cream. Remember, everything on this curve is the equilibrium price for pie given the price of ice cream. And everything on this curve is the equilibrium price of ice cream given the price of pie. And so where these two curves intersect means they are both simultaneously in equilibrium at that set of prices. In this case, $6 for ice cream, $12 for pie. Okay? So now we have identified a set of general equilibrium prices. So let me go to my whiteboard here, and we can do the algebra on this. Come over here, share that. All right, so let me get to some clean paper here. All right, so here's what I was just saying a minute ago. Suppose we have pie. No, make that ice cream and pie. We have these two markets. And let us suppose that we are simultaneously in equilibrium. I'm going to use IC for quantity of ice cream. Here's price of ice cream. I'm going to use P for quantity of pie. Price of pie. I better make this pie so that it doesn't look like a price. And here's my supply curve for ice cream. Here's my supply curve for pie, and here's my initial demand curve for ice cream, and here's my demand curve for pie. I'll make this very elastic. Now, if we're initially in equilibrium here at 6 and 12, that tells me that of the arguments in the demand, the determinants of demand, that specifically it would have to be the price of pie is 12. And this one would have to be specifically the price of ice cream is 6. So I'm not going to worry about quantities because we're seeking prices in this particular case. We want to demonstrate that they exist. So let me suppose I'm in a general equilibrium here. Both markets are at rest, but I'm going to suppose that there is some enormous fruit crop disease that sweeps across the country, and all the cherries and all the fruits that they make pies out of have a greatly diminished harvest. And that means now that the price, the supply curve for pie is going to shift left. And so we're going to have a new equilibrium price of pie. Well, when the price of pie goes up, then the demand for ice cream goes down. So, as the price of pie goes to 14, now the demand curve is going to be depending on a price of pie equal to 14. So that means the price of ice cream is going to fall. But if the price of ice cream falls, then that's going to cause the demand for pie to rise. So the price of ice cream equals 5. And what that means is then that the price of pie is going to go up. So let's say it goes to $14.50. That means that demand for ice cream is going to fall because the price of pie is now higher, $14.50. And so let's say price of ice cream falls to $4.75, demand increases, and so on. So price of ice cream is $4.75, and this keeps up. Now, if the economy is stable, and we observe that it is, then each of these interactions will diminish in its magnitude until our economy would reach a new set of general equilibrium prices and quantities. Right? So I've drawn it so that this shock, this supply shock that started this interactive process between these two markets, that each of these effects gets smaller and smaller and smaller. And so eventually we're going to arrive at a new set of general equilibrium prices. As you can see, it's going to be a higher price of pie and a lower price for ice cream. But the key feature here is that the effect of this crop problem that affected the supply side of the pie market also has an impact on the ice cream market. So as people buy less and less pie, obviously they're going to buy less and less ice cream. The consequence of that is that the price of ice cream will fall, and that will stimulate an increase in demand for pie, which will cause an even greater increase in pie than the original supply shock did. Now, my strategy here for solving for this set of general equilibrium prices, as I said, for this competitive general equilibrium prices, is to establish P star for ice cream for all prices of pie, and to establish the value P star for pie for all price of ice cream. And then I put the two together. Then I solve jointly for both P star ice cream and P star pie. That's how I'm going to do this. And I'm going to do it through those market clearing curves. So, what we were saying before was this. Here's the market for ice cream. So here's my quantity of ice cream, price of ice cream, and I'm going to hold supply constant. We're just going to focus on this demand linkage between these two markets. And so, as I said, I pick any price I want for pie. So I pick, let's say, price of pie is 6. So here's my demand for ice cream when the price of pie is equal to 6. And what do I get? I get, what is the market clearing price for ice cream? Well, let us say it's 12. So my market clearing curve, I have 1 point on my market clearing curve. And this is for the price of pie. This is the market clearing price of ice cream for those given prices of pie. I don't know whether this is the market clearing price of pie or not. I have no idea. It doesn't matter. I'm just trying to identify the market clearing prices of ice cream for all prices of pie. So then when the price of pie is 6, when the price of pie is 6, the market clearing price for ice cream is 12. So there's 1 point. Now I let the price of pie rise to 8, let's say. As a consequence, demand for ice cream falls. And let's say demand for ice cream falls such that the new equilibrium price is 10. So there's another point on my market clearing curve. And suppose then the price of pie is, let's say, 6. Market clearing price over here is 8. Oh, no, it can be 8. It has to be, let me make this 10. It's 10. And this is 8. So here's another point. And as I said before, if I think about you actually choosing all prices for pie and looking at the equilibrium price of ice cream, then I get this. So this is my market clearing curve for ice cream. And this is the equilibrium price of ice cream. That's why I call it the market clearing curve for ice cream, because it is the equilibrium price of ice cream given the price of pie. Now I'm going to do the same thing for pie. So here's the market for pie. So here's my quantity of pie here, here's price of pie, here's supply curve for pie. And we're going to put the market clearing curve for pie over here. And so what I do is I establish some initial price for ice cream. So I suppose the price of ice cream is $2. So this is demand for pie when the price of ice cream equals $2. And let's suppose that the market clearing price for pie is, I don't know, $14. So now here I'm going to put the price of ice cream, and my dependent variable is going to be the equilibrium price of pie. So I have this relationship here, 2 and 14. So when the price of ice cream is 2, the equilibrium price of pie is 14. And the price of pie goes up to, or price of ice cream goes up to $6, let's say. The equilibrium price of pie falls to 10. So I get another point. Price of pie, so ice cream is 6. The equilibrium price of pie is 10. And a third point here, let's let the price of ice cream get really big. Price of ice cream, I don't know who would buy it at $12, but somebody might. And let's suppose that that is 6. So we have 12 and 6. Here's my market clearing curve for pie. Now, here's a complication that gets introduced. My market clearing curve for ice cream has the price of ice cream, the equilibrium price of ice cream on the vertical axis, and the price of pie on the horizontal axis. This curve, the market clearing curve for pie that I just generated, has the equilibrium price of pie on the vertical axis and the price of ice cream on the horizontal axis. And I want to overlap these two curves. So what I need to do is I'm going to flip the axes of ice cream and pie so that I can draw them in the same space. So I'm going to have my drawing now with the price of pie on the horizontal axis and the price of ice cream Well, this one's easy to translate because it's already that way. So I've got the market clearing curve for ice cream. But I have to take this one now and flip it over, invert the relationship so that I have the equilibrium price of pi on the horizontal axis, remember? So when I do that, I get this curve here. So this is pi. I have my two market clearing curves together, and here where they intersect is my solution. That is the set of general equilibrium prices in this two-market competitive economy. So I'll do the algebra now, but this is exactly what I'm going to do. I'm going to first find the equation for the market clearing curve for ice cream and the equation for the market clearing curve for pi, and then I'm going to solve those two curves, those two equations simultaneously. And I get then my general equilibrium solution. Now, I'm going to use the example that's in your textbook so you can refer to that. But so here's our ice cream market. The quantity demanded of ice cream is equal to 85 minus 4 times the price of ice cream, 4 times own price, minus 3 times price of pi, the complementary good. So here's where the relationship exists on the demand side. The quantity supplied for ice cream is equal to 5 times own price minus 5. And in the pi market, the quantity demanded of pi is equal to 110 minus 5 times own price minus 4 times price of the complement ice cream. And the supply relationship is 3 times own price minus 10. All right, so let me find the market clearing curve for ice cream. What am I looking for? I'm looking for the equilibrium price of ice cream as a function of the price of pi. So what do I need to do here? I need to set quantity demanded, 85 minus 4 times the price of ice cream minus 3 times the price of pi equal to the supply of ice cream, which is 5 times the price of ice cream minus 5. Okay, this is my equilibrium condition. Quantity demanded equals quantity supplied. So let me put these together. What do I get here? I get something like, let me collect my terms here. I get 9 times the price of ice cream is equal to 90 minus 3 times the price of pi. Divide both sides by 9, what do I get? I get the price of ice cream, remember this is the equilibrium price of ice cream, is equal to 90 over 9 minus 3 over 9, which is 1/3 times the price of pi. This is the market clearing curve, is the equation. Curve for ice cream. So if I were to draw this out, what would I have? I would have the equilibrium price of ice cream I've got on this axis. This is price of pi. It would look like this. It would have a vertical intercept of 10 and a horizontal intercept of 30. All right. Market clearing curve for ice cream. Now I need to do the same thing for pi. So what do I have here for pi? I've got quantity demanded is 110 minus 5 times price of pi minus 4 times price of ice cream. And I have to set that equal to the supply for pi, which is 3 times price of pi minus 10. Do as I did before. I'll collect my terms. I get 8 times price of pi is equal to 120 minus 4 times price of ice cream. And divide both sides by 8. What do I get? I get, again, this is now the equilibrium price of pi, is equal to 120 over 8, or 15 minus 4 over 8, 1/2 price of ice cream. So this is market clearing curve for pi. All right, let me draw this one out. This is price of ice cream, price of pi. It has an vertical intercept of 15 and a horizontal intercept of 30, not so straight. But like I said, I need to flip this so I can put them on the same picture. So that means I'm going to invert my relationship, my axes, so that I'm now going to have, I can do that, I'll just flip my intercepts around, and that gives me now the market clearing curve for pi. These are both identical, only I have taken the value on the vertical axis, so the market clearing curve for pi, and put it on the horizontal axis, and the value of ice cream price horizontal axis put on the vertical axis. So what do I have now? I've got the two together. I've got this one for pi, 30 and 15. This is price of ice cream. This is price of pi, 30 and 15. So this is all for pi. And for ice cream, what do we have? We had 10 and 30. This is P star for ice cream. And right here at this intersection then gives me my general equilibrium set of prices. Remember, this is the equilibrium price for pi down this axis here, equilibrium prices for ice cream in that axis, and right where they coincide, where these two intersect, would be the equilibrium price in one market also generates an equilibrium price in the other market. And same is true for both goods. So let's then go ahead and do the algebra here. What do we have? We have two market clearing curves. So what were my market clearing curves? They were this. They were for ice cream was equal to 10 minus 1/3 price of pi, and for pi, it was 15 minus 1/2 price of ice cream. Now my strategy here, I'm going to solve it simultaneously. I'm going to do it an easy way. I'm going to substitute P star for ice cream, which we said was 10 minus 1/3 price of pi, for price of ice cream in the market clearing curve for pi. So what do I get? I get P star P is equal to 15 minus 1/2, but I'm going to put in the market clearing price for ice cream expressed in terms of its relationship with price of pi. All right, and now I have one equation and one unknown. This is equal to what? 15 minus 1/2 times 10 is 5 plus 1/6 price of pi. These are the same price of pi. So I get, let me take this 1/6 to the left-hand side. So I get 5/6 price of pi is equal to 10. So the price of pi, then equilibrium price of pi, general equilibrium price of pi is going to be 60 over 5 is 12. And then that means the equilibrium price of ice cream is going to be equal to, what do we say, 10 minus 1/3 price of pi, 12 over 3 is 4, or 6. So those are my sets of equilibrium prices here. And, you know, if I were to look at equilibrium quantities then, you know, the equilibrium quantity of pi would be equal to 3 times its own price minus 10, which is 26, and the equilibrium quantity of ice cream is 5 times its own price minus 5 equals 25. So that's my solution. Here, I get 12 for pi, 6 for ice cream. So 12 here and 6 here. Is my general equilibrium. And as I say, you know, the math, it gets more complicated, but the essential concept doesn't as you go to a higher number of markets. You know, sticking with 2 markets, we can draw it. You know, once you get to 3 markets, you can't draw it anymore. And the math increases in complexity. So one of the arguments here that, you know, one of the shocks to the market is that your authors suggest is, suppose a tax of $3 is levied on ice cream. All right. Statutory incidence supply side. So that means now sellers of ice cream keep whatever they sell the ice cream for, less the amount of tax that they have to pay. So I've got a new equilibrium supply equation for ice cream, which is going to be 5 times, all sellers care about is covering their marginal cost. So it's the net of tax price that they're worried about, minus 5. So this is going to be 5 times price of ice cream, minus 15, minus 5, which is to say 5 times price of ice cream, minus 20. Now, you know, our demand side stays the same. So demand for ice cream stays 85 minus 4 times price of ice cream minus 3 times price of pi. So with this new supply relationship, let's get a new market clearing curve for ice cream. It's not going to be the same because we have a new supply curve. So I'm going to set 85 minus 4 times the price of ice cream minus 3 times the price of pi equal to now 5 times price of ice cream minus 20. So what does this give me? This gives me 9 times price of ice cream is equal to 105 minus 3 times price of pi. So the price of ice cream then is equal to 105 divided by 9. Which is 11 2/3. All right, so the equilibrium price of ice cream is now going to be equal to 11 2/3 minus 3 over 9, which is 1/3 price of pi. So that means that recall earlier that my market clearing curve for ice cream had an intercept of 10. Now it's going to shift up. So, price of pi, the market clearing curve for pi is unchanged, so 30 and 15. So it was 30 and 15. And here was, this was for pi, and for ice cream was 10 and 30. Now it's going to be 11 and 2/3 times, this is going to be what, 3 times 6 is 35. So the effect of this tax, which was 12 and 6, I believe initially, is going to be to lower the equilibrium price of pi and raise the equilibrium price of ice cream. So the tax doesn't have incidence in just the ice cream market, it also has an incidence in the pie market. So in order to get this new one, what do we need to do? We need to set 11 and 2/3 minus 1/3 price of pi. So I've got price of ice cream, so 11 and 2/3 minus 1/3 price of pi, but price of pi, I want to use here its equilibrium price. So I need to go to the market, which is the market clearing curve for pi, and so its equilibrium price is going to be 15 minus 1/2 times the price of ice cream. Doing exactly as I did before. So what do I have now? I've got 11 and 2/3 minus 5 minus 1/6 price of ice cream. Let me make sure I got this all right. Price of pi is 15 minus 1/2. All right, I think I do. So bring this to the right-hand side, I get what? I get 7/6. This has to be a plus, I'm sorry. Let me erase this. So again, it's going to be 5/6 price of ice cream is going to be equal to 6 and 2/3, which is 18, it's 20/3. So price of ice cream now, I'm looking at the new equilibrium price of ice cream, is going to be equal to 120 over 15 8. So the price of ice cream went from 6 to 8 when the $3 tax was levied on the sellers of ice cream. And the incidence of that tax is $2 on buyers of ice cream, $1 on sellers of ice cream. But now the price of pi, remember it was 12, is going to be 15 minus 1/2 of 8, or 11. So there's now an incidence of this tax on the sellers of pi. They get $1 less for their pi, but the consumers of pi benefit from a $1 decrease in its price. But so that example was intended to show that a tax in one market, when we looked at it, in chapter 15 in a partial equilibrium context, that tax in one market also has incidence in other related markets. All right, so I'll stop there And we'll talk about efficiency now across the economy, which is the balance more or less of chapter 16 when we meet on the next class meeting. All righty. So I will see you then. And till then, stay happy and healthy. Bye-bye.